Hello, Ma'am Aubrey here, and welcome to the first lecture for our science course, The Formation of the Universe. In order to understand Earth and how it was formed, we have to look into the very beginning of everything, and that's the formation of the universe. So, for the next series of lectures that we will be having for Module 1, this is our learning objective. Describe the characteristics of Earth that are necessary to support life. And in order to identify those characteristics, we have to look into the universe. Okay, so before we dive into the formation of the universe, let's differentiate these two concepts, theory versus law. We have a lot of theories and laws that are quite famous in science. We have the theory of evolution, the theory of Big Bang, the theory of special relativity. Then you have your laws, which, for example, your E is equal to mc squared, the laws of motion. Okay, F is equal to ma is the first one. So what's the difference between the two? Of course, they have similarities. Both started with a hypothesis, but since these hypotheses are backed up by certain hard evidences, they are eventually accepted in science. They can be used to make predictions about the future and can be further revised if we found more phenomena which needs us to revisit our theories and laws. Okay, but what's the difference? For theory, it explains why natural phenomena occur. It's more of a body of knowledge, of a set of explanations. So, for example, the theory of evolution explains why the living things we observe today are like that, while for law, it's a summary. Usually, you can summarize it in a simple line of mathematical equations. So, it summarizes a set of observations about natural phenomena. Okay, so scientific law, it can be reduced to a mathematical statement. That's why F is equal to ma. If you compare that to the theory of evolution, if evolution does not have a particular formula, so it's not considered a law, it's considered as a theory. These are, for law, it's based on empirical data, while for scientific theory, it's a body of evidence or observation of a particular phenomena. So regardless, so that they are two different forms, both are based on evidences, and we can use them to apply them and predict the future. Okay, so let's go to the next slide. Let's go back to this question. How did the universe begin? So since time immemorial, I think human beings have been trying to answer these questions, and it depends on which you ask, and a different person will have a different answer. So in terms of mythology, there are several mythologies which try to explain the beginning of the universe. For example, in ancient Egypt, people believed that the earth was a result of a marriage between the god of the ocean and the god of the sky. So the god of the ocean, god of the sky, gave birth to the earth. Okay, so that's for the mythology of the Egyptians. We also have the famous divine creation. In the beginning, God created heaven and earth. So some religions state that the earth was made by an almighty God. There is also the philosophical theory of eternity. There is actually no beginning. So there was no beginning. When you ask how did it all begin, there's no beginning because it's all an eternity. Life has no beginning and no end. There's just life. Okay, but for science, we have a particular branch that tries to study and answer this question. Okay, and that's cosmology. So cosmology is a branch of astronomy that involves the origin and evolution of the universe from the Big Bang to today and into the future. So take note that cosmology is not only answering the question that how did the universe begin, it also tries to answer the question how it will end. Because what's the purpose of knowing what has happened before if we can't predict what will happen next? So that's our cosmology. Okay, so for cosmology, the most accepted scientific theory for the beginning of everything is the Big Bang theory. So you may know that Big Bang is not an appropriate term for this theory. It was not originally named Big Bang theory. There were some skepticism when this was proposed, and there was misunderstanding when it comes to the media and the press. They are stating that there was an explosion and then the universe came, the Big Bang. So they were actually making fun of the theory. That's why they called it the Big Bang theory. But since the name stuck, we stick with the name Big Bang theory. Okay, so for clarification, the Big Bang is not an explosion but a rapid inflation. So if you can recall some animation with sound effects of the Big Bang, that was not true. There was no sound back then, so there couldn't be an explosion like that. It's a rapid inflation. Okay, so the entire universe was infinitesimally small and infinitely hot, and all matter and energy compressed into one megadense point called the singularity. So in the beginning, there was this hypothetical particle called the singularity. It's very small and very, very powerful, and you could imagine it like a single point, but it's a supercharged black hole, and that supercharged black hole suddenly inflated and gave rise to everything that have ever existed in the universe. Okay, so this, as we stated, the Big Bang theory is the most scientific and accepted theory, and it's still what is the most accurate theory that is explaining what we observe today. Okay, so our universe sprang into existence as singularity around 13.7 billion years ago. So if you're asking, so what happened before the Big Bang event? There was no before, because again, time did not exist before the Big Bang event. So the Big Bang event started everything, the beginning of everything. So matter, energy, time, and everything ever existed. Okay, so let's go ahead and discuss step by step what had happened according to the Big Bang theory. So in the very beginning, the cosmos, so when we say the cosmos, that's everything. The cosmos goes through a super fast inflation, expanding from the size of an atom to that of a grapefruit. So this is the inflation event that we were talking about. So an inflation event occurred, and that supercharged black hole called singularity started to inflate. Okay, so during that, the inflation started to, the inflation started to spread. But remember that the dense point we call singularity is everything. So that consists of energy, matter, and antimatter. But the good thing about inflation of the universe, it starts to cool down as it inflates. So when the singularity started to inflate, the energy and matter started to separate. And when energy and matter started to separate, there are now electrons and quarks that are being formed. Then once the universe expanded some more, and that's further cooling, it permitted the formation of quarks, and the quarks clumped into protons and neutrons. So further expansion, the universe cooled down further, and the protons and neutrons are now stable enough to combine. Okay, so once those protons and neutrons combined, it give rise to our first elements, your hydrogen and helium. And since the universe has expanded enough, light can finally shine through this particular area. But there was no light yet. Okay, but during the 1 billion years, the universe is big enough, and there are now enough hydrogen and helium gas in our universe, which form the giant clouds. And the giant clouds actually collapsed into itself, which led to the formation of stars. Okay, and then those stars were so powerful and had so much energy that it was enough to trigger the formation of the other elements. Okay, and then the interesting is, so when the stars form the heavier elements, whenever it goes through a supernova event, it spreads the elements to the rest of the universe, thus giving birth to the other components of our universe. So the stars formed further stars. Galaxies cluster together under gravity. Then the first stars spew heavy elements. The first stars spew heavy elements into space. This was what I was talking about. So whenever a star undergoes a supernova event, it spreads the heavy elements into space, and that eventually led to formation of new stars and new planets. Okay, so that's our Big Bang Theory. Okay, so this is a poster that I got from NASA. So this is showing you the cosmic inflation. So the inflation of our universe. So in this point here, time zero is labeled as the Big Bang event. And during this period, you have a so-called cosmic microwave background. Since the Big Bang event is so powerful, it left like a footprint in our universe, and that's called the cosmic microwave background, and you can still detect it today if you use powerful enough radio systems. Okay, so during this time, the universe started to expand, and you have your dark ages. So during this dark age, this is a period wherein there were no stars yet, so there was no light. But eventually, as the universe expanded, it started to cool down, which allowed the formation of elements and the formation of stars. So as we expanded and expanded, more stars are being formed, and around here we have your formation of the Earth, and we are still accelerating now. And what our scientists can observe is the universe is actually expanding in an accelerating speed.